Algebra class. Our next video is on completing the square in vertex form. The new thing is the vertex form. Completing the square should be review for you from Algebra 1, but it was not an easy thing to remember. So we're going to review a little bit first. There is this song that I don't love the song. It's a little cheesy. It's supposed to help you remember the steps to completing the square. So if you've had a teacher in the past that showed you the song, great. If not, I will not be one that sings it. But if you want to look it up, you can certainly look it up. So here are the steps in more detail than the song gives. And the first thing we're going to do is done for us, which is we want to move that constant, so this 5 right here, to its own side. Why am I not writing? I'm not writing on anything. It changed it on me. Here we go. Okay, there we go. So this 5 has to be by itself, away from the x terms. And once you do that, I like to leave space. Sometimes I do this all in one step, but I like to leave space right here and right here, because completing the square, what it means is we're going to take the left side and create a quadratic that is a perfect square quadratic. And to do that, you take this middle term, this b term, off to the side. We like to show it here, what we're doing. You cut it in half and then square it. So this would be like 3 squared is 9. And you're going to add 9 to the left side, but we got to keep the equation in balance, so we add 9 to the right side as well. And then this will always come out the same. If you do this correctly, it becomes this perfect square. It's kind of like we made it a perfect square. We made it like 25 so that we can write it as 5 squared, except it's a polynomial. So we made it x squared plus 6x plus 9 so that we could write it as x plus 3 squared. So you can, if you factor, or if you multiply that out, you'll see that you get x squared plus 6x plus 9 equals 14. Now, I'm going to put a little star right here because when we're going to do the vertex form, this is where we would do something different. But when we're solving for x, we take the square root of both sides. We end up with x plus 3 because that just undoes the square, equals, and then we have to put plus or minus radical 14. And then we move this 3 over. And you get x equals, and I usually like to put the plus minus in the middle, it just looks cleaner, so negative 3 plus or minus radical 14. And that's it. That's how you would leave your answer in exact form. That is 2 different answers. Both of them are decimals that go on forever. To keep this video short, I'm not going to go through this whole thing. You can try it yourself, and I'm going to give you the answer here in just a sec. So if you want to pause it and do it, you can. It is x equals 2 plus or minus radical 2. But I really want to do the example here because something different happens here. This 2 out front complicates things a little bit. So let's start. The first step is always the same. We're going to move this 9 over to the other side. So we get 2x squared plus 12x. I want to write this right here, plus something equals negative 9 plus something. Now, you can't just jump into this 12 and start cutting it in half and squaring it and putting it here, because that doesn't work with the number out front. So the first thing we got to do is pull that 2 out so that we don't have a number out front, and we get this. Now, this 2 is going to have an effect. We didn't just get rid of it, because this empty space inside the parenthesis is going to have to be multiplied by 2, because everything inside has to be multiplied by 2. So this number and this number are not going to be the same thing written, but they will have the same value. So I'll show you what I mean. So we take our 6 now, same thing as before. we get 9. We add 9 here on the inside so that this inside is a perfect square. And now we can write it as 2 times x plus 3 squared. But over here, I really didn't actually add 9 to the left side. I added 9 to the inside, but as far as the whole left side goes, I added 18 because I got to do 2 times the 9 and add 18 right here. And then that equals 9. Okay, then I can divide by 2 to get rid of that 2. And I get x plus 3 squared equals 4.5. You can leave it like a fraction if you want to. Square both sides. You get x plus 3 equals plus or minus radical 4.5. And then for our last move the 3 over, you get negative 3 plus or minus radical 4.5. So that's what you do when there's a number out front. So we're going to move towards vertex form now. This here says recall the standard form of a quadratic equation. Standard form is pretty simple. It's just y equals a x squared, some number out front, plus bx plus c. That's the standard form. Vertex form looks a little different. Vertex form looks like this. Y equals, some letter a can be there, but it's x minus h squared plus k. We use different letters so that it's not confused with the other forms of the quadratic. And then the reason why it's called vertex form is because the vertex then is the h value and the k value for the x and y value of the vertex. So h and k is just like a specialized x and y that mean the vertex. So keep in mind that inside here, it feels like it's the opposite. So if it says x minus 3, then the vertex is at 3 something. K is the same. It's positive k, positive k. You don't make any switches at all. Okay, before we do any conversions from standard to vertex, let's just practice using or finding the vertex given that form of the equation. So remember that this is like our minus h, and this is like our plus k. So our vertex then is plain old 6, because we switch the sign on the inside, and then we don't switch it for the k. So 6, 4. So down here, this would become negative 5, negative 3. Moving down further, you could get this one. It's helpful to think of this in the same way the other ones are. But, why would we not need the parentheses? Well, it was because we probably didn't add or subtract anything. So x plus 0 squared plus 7.25 would give us a vertex of 0, 7.25. Now we're going to go the other way around. They're going to give us a vertex, and actually they have to give us the direction of the parabola so that we know if it's positive or negative. So this one opens upward, which is a positive. Remember that if it opens upward, it's happy. If it opens downward, it's sad. So you start by writing y equals, we'll do a sign first, positive, so I don't need to write a sign, parenthesis x. Now I want the opposite sign of this, so I want negative 4 on the inside. So minus 4 squared, and I want to keep it the same on the outside. Go ahead and try the other ones, B, C, and D. See if you can get it. Okay, if you did it right, you should have gotten these 3. The last one you didn't need parentheses, but if you did put x plus 0 in the inside, it's not wrong. Okay, and the last bit here is where we actually do the conversion. So we're going to start as if we're solving for x using the completing the square method. So that means I want to move that minus 5 away from the rest of the x terms. So let's start by saying x squared plus 4x plus something, because I'm going to replace it with something else, equals, and remember I had to move it over by adding. I know, imagine like this is 0, right? I'm just imagining it over here instead. So positive 5 plus something. So I take my 4, my b term, half it, square it, you get 4 again. You add that to both sides. There's no number out front here to worry about. And then if you want to, after you do these a while, you realize you don't really have to factor. You just take half of this term. So like 4 just is 2. It's always half of this middle term squared equals 9. Now this is where I put the star on that first one because we're not solving for x. We're just rearranging the formula, the equation, to look a certain way so that we can get the vertex super easy. So we're almost done, actually. All I need to do is drag this 9 back over to join the group, and you get x plus 2 squared minus 9, and we can stick our equals f of x back on. It's still f of x. We didn't actually change the value, and if you wanted to, you could graph the original one and our new one, and you should have the exact same parabola. We didn't want to change it. We just wanted to write it in a different form, in a form that I can now say with the vertexes really easily. So it says without the calculator, we know that it's -2, -9, because I'm just reading these two values here. Here's one more. This is a tricky one because it does have a number out front. So why don't you go ahead and give it a try. I'm going to pause it and do it myself. All right, that's what you should have got. So you had to pull that -3 out, and then you just had to really remember right here to make it a -3, because we're not really adding just 1 to the side. We're adding -3 because if you distribute it, it's a -3. Okay, that is it. Good luck on the delta. Have a good night.